Welcome back to part 3 of our series on circular linked list. So technically I recorded part 3 yesterday. I thought about it and I was like, you know what? There's probably some stuff I maybe glossed over a little bit. And so I decided that I'm just going to re-record that part only because I want to make sure I explain some stuff in detail. So we left off on the last video talking about list size. In this video, we're going to start off by defining a new method about our particular circular list. It's going to be getting the previous node. So let me open up my previous one. So when we get the previous node, really what we're talking about is if we were at node 2 and we want to get node 1, how would we do that? Well, that's what this method is going to do for us. Given a particular reference node, get the node that comes before it. So this method will take a reference node argument, which will just be another node in our list. And then in this situation, like in previous ones, we do want to handle certain errors. And so in this particular one, we'll do something like, for example, if the reference node is none, then raise a value error. Or you could even say, or if self.head equals none, then raise another value error, which is basically saying, hey, the self.head is none as well. So basically you have an empty list in that situation. So if they give us some kind of weird argument, or if they give us a head that, for example, is an empty list, we have a problem. Okay, regardless, we've handled that situation. Now we're gonna basically get the previous node, and this is actually gonna be a pretty straightforward one. The first is we're gonna define the first node. That's obviously gonna be our head. And so that's gonna be equal to self.head. And then from here, really all we're going to be doing, and again, it's pretty straightforward, is keep going until you reach the desired node. So keep going until you reach the desired node. And so what that's going to look like is while current dot next node does not equal reference node, then reassign current to equal the current node, but the one that comes after it. Why did I write it specifically like this? Well, remember, we want the node before our reference node. And so really what this is saying is, hey, if the node that comes after the one that we're currently on is the reference node, it means we've reached the node that comes before it. And so in this situation, that's great. Then all we're going to do is we're just going to return that current node. That's really all we're doing. So that's how this method would look. And from here, what we can do is we'll talk, I think I already have one in there. I'll make sure to enter this one. And then from here, what I'm going to do is I'm going to define, so we'll just say grab the second node, and we'll call it second node. So that's going to equal our circular list dot self dot head. Oh, sorry, not dot self, dot head. And then we want the node that comes after it. And then from here, we're going to use that circular list to basically, get previous node. And then we're going to pass through that second node. And then I'm going to print the piece of data that belongs to that node. And so you can see that it is 20. So if I get the second node that's 90 and I want the node before it, that would be the first node. So it did get the correct previous node. So that's getting the previous node. Let's move on to the next method. The next method is going to be a little bit more complicated, but it's not anything crazy. With this one, we're going to be doing reversing our circular list. What that means is that 50 would now be our first node, 90 would be our second node, and then 20 would be our third node. So we're basically just flipping the list. Now, I will be honest, this one did confuse me a little bit. In fact, I had to get some help on Stack Overflow. But once I kind of saw it after seeing what was done, it made a little bit more sense. But what I'm probably going to do is I'm just going to write most of the code first. I'm not going to do a ton of explanation just because it's kind of hard to understand really what it is until you're kind of seeing the entire code in its entirety. So Same here. What we're going to be doing is we're going to be handling a situation where potentially we have an empty list. Now, in this example, I'm not going to have any inputs, so I really just need to test to make sure, hey, if self.head is none, then we know, hey, we've got a situation where we have an empty list, which is not good. And then from here, we have to initialize a few variables. I'm not going to go into too much detail at this point as to what they are, but we're going to have one, which is going to be called last. That will be self.head. The next one is going to be current, which will be self.head. Previous is going to equal self dot, what is it? End. And then next is going to be current, so the current node, but the node that comes after it. So at this point, the current node is just simply the starting node. The previous node is the one that comes before our current node. And then our next is going to be the node that comes after our current node. I'll explain what last is in a little bit. Okay, so now that we've done that, we're going to reassign the last node to the head's next node. So here's what we're kind of going to be doing. So we're going to be taking our current node. We're going to say, okay, the node that comes after it is now going to be the previous node. So what that means is the current node's next node is now going to be the tail. The current node's next node is going to be the tail. It's going to point to the tail. And then from here, we're going to reassign the previous. So we're going to say the previous is now going to be the current one. That kind of makes sense. So, okay, we've done our reassignment. So now the previous one is the old current one. Okay, so reassign the previous to the old current. Now, keep in mind, too, we haven't really reassigned the current. We're literally just saying, hey, the previous is now the self.head. So at this point, the previous has now become self.head. So the old current node now becomes the old next node. And so that's going to say current is going to equal next. Okay, so we've moved now. If we had 3 nodes, the current is now the second node. Okay, so we're just kind of just moving along. And then from here, we're going to start our while loop. So we've already done one reassignment outside of our while loop, but now we're going to start our new while loop. And then this is where I'm going to talk about that last variable. So keep going until you reach the head again. This is kind of what threw me off a tiny bit when I was trying to look at this code, because I saw current and I'm going, it wasn't current. I was seeing last. I'm like, last, what is this last? It's the last one in our list if we had done a full traversal. So really, you need to think about this last as saying, hey, if I do a full traversal, when do I reach the last node in my list again? Well, it's when you reach the head again. And so what this is saying is keep going until you've done a full traversal. But then you're kind of saying, well, why did we do this assignment up here? Well, think about it. If we didn't do this reassignment, so just say I had comment this code out, right? Then current would still be self.head, and then last would be self.head. So basically what would have happened is that while loop never would have executed. It would have just basically jumped right past it because the condition would have already been met on the first iteration. So that's why they did this reassignment outside the while loop. And then they say, okay, and once you've done the first reassignment, now you can do the rest of the ones using that while loop. But really, it's that first reassignment that has to be done outside of the while loop. And then from here, it's pretty much identical. So now it's going to be next equals current.next node. And then it's going to be basically these guys right here. We're just taking those lines and we're putting them inside of our loop. So we're doing the same reassignment. It's just we're now adding it inside that while loop. And so you might be saying, well, what's going on here? Why are we reassigning the next one? Well, remember, we've got to make sure we set up the next node before we get down here, because otherwise it's going to be using the old next, which we don't want. So in a sense, if we only had 3 nodes, it would be like we're going to that third node. Again, you're going to probably have to do this on paper, but if you only had 3 nodes, that's basically taking the current node at this point, and we know the current node, we've reassigned it up here to the second node. So now we're saying next is the third node. So reassign the next node to be the current one, but after grabbing its next pointer. Again, I know, a little confusing, but hopefully that makes it a little bit easier. We do need to make one final reassignment. That's connecting the tail to the head. And so what we're going to do here is we're going to say one final assignment. Well, not technically one final assignment, but one, I would say, complicated assignment. One final reassignment. Make sure the last node points to the head. And so we're going to say current.next node is going to equal previous. Why, oh why? Well, how would I say this? When you're doing this loop, eventually the previous will become the, what is it? It's going to become the head again. And so really what you're saying is you're taking that current node and you're just having it point right back to the head. That's going to be happening inside the while loop. So that's why you're setting up like this, because the previous, once that while loop is going to be done, is going to be the head, and then that current node is going to be the last node in our list. And then from here, then redefine the head and tail. And so we'll say self.head equals the previous, and then self.end is going to equal your current. So that's just setting up so that way if we do insertion operations afterwards, nothing's going to really be kind of screwed up. Okay, so now that we've done that, let's test it out to make sure it's all working right. Where are my notes? Oh, I got to move it to the second one. My bad. Oh, no, did I not? Oh, that's why. Sorry, it was on page 1. Okay. So from here, we're going to say reverse the list. And so we'll just call circular list dot reverse. And then what we're going to do is we're going to say after reversal. So we're going to see how does our list look after reversing it. After reversal. Okay. Hopefully everything's good. Okay, perfect. So 50 is now the first node, 90 is still the second node because that was in the middle, and 20 is now the third node. So that is the final node in our list. So that's reversing our linked list. We have one final topic we're going to talk about. Technically, I will be showing on the documentation 2 examples of doing this, but basically what we're going to be doing is we're going to talk about splitting a list. So assuming we're given one circular linked list, we want to split it into 2 lists. They don't necessarily have to be even lists, but we do expect 2 lists to be created after splitting it. Now, there were 2 ways that I saw of doing it. One of them, I mean, at least me personally, I think it's a little bit more confusing. I don't necessarily understand entirely how it works to a certain extent. And then the second method is kind of one where I took method 2 and I just made a couple little changes. Me personally, I think method 2 is a lot easier to understand, where method 1, you definitely would have to draw it out to understand really what's going on behind the scene. So I'm not going to do method 1. I will show you what method 1 looks like, and I'll kind of just give a high level overview of really what it's doing at each stage. And then I'm going to do method 2 just to demonstrate. But I will have method 1 inside the documentation that I post on GitHub. Alrighty. So with this one, there's 2. Basically, we're going to call it split list. This is the complicated one. And so all this method is going to do is it's going to pass through 2 arguments. They're going to be 2 empty circular linked lists. And then once we start this method, we're going to define two variables. Both are going to be pointing to the head. One is going to be called slow pointer. One is going to be called fast pointer. We'll still add a condition so that way we can handle an empty list. But really the kind of, I would say, complicated part here is this little section right here. So basically what this little section is going to do is it's going to traverse the list, and two conditions have to be met in order for this while loop to terminate. The first one is that first pointer dot next node does not equal self dot head, and first pointer dot next node does not equal self dot head. So if both of those do not equal self dot head, then it will keep looping. But if they both equal self dot head, it will terminate. Well, all this is going to be doing is for odd nodes, it's going to make it where the fast pointer dot next node will become the head, and we'll basically have that fast pointer be the head of our first list. And then for even nodes, fast pointer dot next node will become the head. And again, we will be using that for the first load. And then from there, what we're going to be doing is we're going to be reassigning that to the first list. Sorry, my phone's ringing. And then we also have a slow pointer. So the slow pointer is going to also be traversing the list, but it's going to be always one behind the fast pointer. That'll make a little bit more sense when we go to the second part. So if the fast pointer .next is the head, just stop one node before to get the last element of our list. And really, all this is doing is to make sure that we don't actually have the first element. We basically don't have the first element in our list. And then from here, we're going to say, okay, for our first empty list, the head is going to be the old head in our original full list. And then if self.head.next node does not equal self.head, so basically if we just have one element, then head2.head is going to equal slow pointer.next node. So if we actually have enough elements to make two lists, then this is going to have that second list. It's going to have head2's head be the slow pointer. So slow pointer and then everything after. And then all this is going to do is it's going to make sure that the fast pointer.next node, it's going to equal the slow pointer.next node. So this is really just making it circular. And then, the second one is it's going to make the first half circular. So it's going to say, hey, slow pointer.next node is going to be self.head. And then from here, it will create both lists and you'll get them sent back. So that's kind of the more complicated one. Again, I personally struggled with it a lot. I couldn't really wrap my head around it. I'll show you an easier way to do it. It might be a tiny bit slower, but technically there's a way we could even make it the same. But that's for a second. That's for another discussion. So what we're going to do is we're going to create a new method called SplitList. It's going to be head1 and then head2. And then from here, we're still going to do a couple things. So obviously, one is going to be, hey, if you got an empty list, we can't split an empty list. We'll do something like, we can't split an empty list. Okay, that's fine. So in this situation, what we're going to be doing is we're going to be calculating the midpoint of our list. And so once we have that midpoint, anything that comes before it is going to be going into list 1, and anything that is the midpoint or greater is going to be going into list 2. So the first thing that we got to do is we got to get our list size. Well, luckily up above, we already have a method that will calculate the list size. So what we'll do is we'll grab the list size, and we will say list size equals self.list size. So this will obviously return the list size. And then we're going to grab the midpoint. We got to make sure that we calculate it correctly because we don't want a float. We want just a whole number. So we'll say mid equals list size. And then I think that's floor division if I remember correctly. But basically, it's going to round it to an even whole number. And then from here, we can now start doing kind of what I would say is the fun stuff. Where are my notes? Hold on. I got to check really quickly to make sure. Okay, there it is. I misplaced my notes because that's obviously what happens. So grab the first node, and we'll call it current, and we'll say it's self.head. And then we're going to have a counter. So basically this counter is going to increment as we're looping. So really what we're going to be having is a condition. So we'll say while the count is less than the list size, keep going. So go while the count is less than the list size, -1. I'll explain in a second. Count equals 0. We're going to start at 0, and we'll say while count is less than or equal to list size -1. Okay, so what is going on here? Well, we're going to increment this each one, but you might be asking, why did I do list size -1? Well, if I start at 0, 0, 1, 2, 3, that's 4 elements. Well, if I have 3 elements, 0, 1, 2. So basically, it's always got to be 1 less than the actual list size itself, because the list size is going to return, if there was 4 elements, 4. So I want to go 1 less than the actual list size because I'm starting at 0. That's why I'm doing that. So from here, I'm going to say grab the data, and we'll just call it data, and that will equal current.data. And then we'll just ask a couple questions. If it's less than the mid, put in list 1. And I'll say if count is less than mid, head 1, insert beginning. So I can just put this in the beginning of our list and just do that. And then we'll say if it's greater than or equal to the mid, then put it in list 2. And we'll say if count is greater than or equal to mid, then have it have head 2, insert end. I'll explain that in a second. And then we'll say grab the next node. And we'll say current equals current dot next node. And then we also want to increment the counter. So increment the counter. And so we'll say count equals count plus 1. All right. I think that's everything. I always get these two mixed up if it's header beginning. I'll explain that in a sec, but I'm going to grab that. Because remember, it does take 2 different ones. Head 2. And then we are going to say circular list dot split list. I'm going to pass through head 1 and head 2. And then from here, what was I going to do? I got to move my notes really quick. I can't remember where I put them again. I keep doing that. You should see how I do my desk sometimes, because I swear to God, I do it to myself where I put notes on one side, I put it on the other side, and before I know it, I'm all over the place. Okay, so what I'm going to do is I'm going to say list 1, and then list 2. And then it's going to be head 1 dot traverse, and then head 2. Yes, 90 and 20. Yes, okay, perfect. Sorry, I had to think a little bit. But as you can see, it did split it, and then the nice thing is it kept the order. That's why I did insert end, is because I want to always insert at the end of the node if it's list 2, so that way it maintains that order. Naturally too, I mean, really, it's really which one you choose to be equal, because if it's an uneven list, then list 1 would always be the smaller one, and then list 2 would always be the larger one. So again, it's up to you how you want to do that. This is kind of just saying, hey, once you've done that, you just got to make sure that 1 goes the end and then 1 goes the beginning. Again, I found this method easier. I could understand this one. The other one, I was just struggling all over the place because it was really hard to kind of comprehend that fast pointer and that slow pointer. I really kind of had to draw it and everything like that. Some people might say, well, you got to traverse the list again because you got to get the list size right. Well, yeah, technically, but what you could do, if you wanted to, why couldn't you just have your circular list have another property, which is count, right? And then all you're going to do is when you create a new list, you would just have count initialized to 0. And then if you do an insertion operation, you add 1. And then if you do a deletion operation, you delete 1. So technically, just technically, you could potentially actually have it where you wouldn't even have to traverse that list here if you did something like that. Now, there's a trade-off. Obviously, your circular list is now going to take up more space in memory. But to me, I think that's personally a trade-off that you would have to debate. I don't think it's going to take up that much space. But that is an option where you don't have to technically traverse it. And then technically your operations are still going to be the same. It's still going to be O of n, but it's just you could make it maybe a tiny bit faster by not having to traverse it. So with that being said, though, if you have any questions about the final video, please put them down in the comments below and I will try to get back to you. If you enjoyed the series, please make sure to like the video. I always appreciate the support. It helps other people find it and things like that. If you want to share it, go ahead, go share it. And then if you're not already, maybe this is the first video you've come across and from my channel, feel free to subscribe. There's definitely more content coming out there. I might take a pause on the data structures for a tiny bit. I'm going to go back to the machine learning stuff. Random forests, that's what we're doing next. Oh yeah. So that's going to be an interesting topic. And then from there, I might be talking a little bit about accessing the Adobe object model from the Win32com library. So we'll kind of see, I'm hoping that there's some kind of methods where we can leverage the export functions inside of that object model. I think it might be really helpful for those of us who get a lot of PDF documents and things like that. So more exciting stuff to come. Thanks again for watching, everybody. We will see you in the next series.